Hi everyone, welcome back to the another video of Niras Academy. So guys, you must have seen this type of the motors. We can see it everywhere from our pumps, compressors, fans, like the majority of the industrial applications, our household application that is having this type of the motor. So this particular motor is nothing but the three-phase induction motor. Well, this motor converts the electrical energy into the rotating mechanical one. So that is nothing but the main principle behind this three-phase induction motor. Similarly, guys, when I was a kid, I used to play with this small DC motor. This particular DC motor is having the two permanent magnets that is enclosed, that is the N and S, around the periphery of a cylinder, and there is a rotor that continuously rotating between these two magnets. So when I connect this DC motor to the DC power source, DC power supply such as 1.5 volt battery, it starts rotating. So over here this electrical energy gets converted into the rotating mechanical. So these two motors are same, but the one is I used to play with that consumes the DC power source, whereas this bigger size that consumes the AC power supply. So over here guys, this AC induction motor gets developed with throughout the years, and that is invented by Mr. Nikola Tesla. Well, he was the pioneer behind the modern alternating current, and he developed the first alternating current induction motor in 1887. He patented his design in the US in 1887. So, Sir Nikola Tesla, I really respect you. Well, this induction motor he designed and he developed, and throughout the years there are several modifications in this three-phase induction motors. So friends, our today's topic is nothing but the three-phase induction motor. How does it works and some of the features of three-phase induction motor we are going to learn in our today's video. So friends, if you are new over here on my educational channel Niras Academy, kindly subscribe it and please press the bell icon. And guys, please share all of my educational videos to your friends, family, social networks, and please keep motivating me so that I can also make some more of the educational, interesting technological related videos. So without wasting any time, let's begin with our today's topic of three-phase induction motor. So guys, as the name itself says that the three-phase induction motor, over here the three-phase power supply which is used in this induction motor, and the induction, it means there is electromagnetic induction. Induction means that is the magnetic flux gets induced from one coil to another coil. So this is known as the induction. You must have heard about the induction cooker, like also the Tesla coil. It is also worked on the same principle of the electromagnetic induction. The wireless chargers, that also works on the electromagnetic induction. So over here the induction occurs in this motor. So first of all, when we talk about the motor, the first thing that comes in our mind is nothing but there are two parts. The first one is the stator, that is the stationary part, and the rotor, that is the rotating part. So now let's talk about the stator. So this stator is nothing but the cylindrical part into which the coils are there. So coils are housed in such a way that it could use a three-phase power supply. Over here guys, you can see this is nothing but three-phase power supply which is there in that particular coil of the three-phase induction motor. We can call it as a stator windings. So this stator windings, these are nothing but the copper coils. So when we connect this to the alternating current power supply, the EMF gets induced. As per the Faraday's law, when we connect a particular coil, when we allow a current to flow through a particular coil, it will produce a magnetic field. So this is nothing but the Faraday's law. So now by using the same law, when we connect the stator windings to the AC power supply, the magnetic field gets induced in this stator windings. And over here the three-phase arrangement is there in such a way that like the magnetic field which is produced, that starts rotating. So over here guys, the rotating magnetic field gets induced over here. And this induced rotating magnetic field is sufficient enough to rotate the rotor, which is housed into that cylindrical stator windings. So what exactly happens in this stator windings, in this three-phase power supply? So when we talk about a single phase line, like when we turn on the power supply, when the current starts flowing through the coil, let's say this one is the red one. Okay, over here guys, this graph represents the fluctuation, the peak value. When the current gets started flowing through the coil, okay, the EMF started inducing, the magnetic flux gets creating in that a coil, in that the red coil. So at one time, only one coil's magnetic flux is there at a higher value. During the next interval, the blue one, that is the blue coil, current started flowing through the blue coil, and the magnetic field is there started approaching to the peak value. Over here guys, you can see this is the graph which represents the rotational magnetic flux which is there in the stator with respect to the direction of the current. Guys, from this animation we can clearly understand how does the rotating magnetic field gets produced. We can see the direction of the rotation and the direction of the current flowing through the coil. So if I increase the frequency, of this alternating current, the rotating magnetic field will rotate very fastly, like its RPM will increase, and ultimately our motor's RPM will also increase. So now I'm talking about the alternating current frequency. So now when we try to when we insert a rotor into this stator windings, and there is a sufficient gap which is present between the stator and the rotor. The rotor is supported by the bearings from both the sides, and it is completely enclosed into the stator winding. The rotor is having a design that is in such a way that it is having a squirrel cage design that is enclosed by the laminations, and on that laminations my copper coil is wounded. So when the magnetic flux gets induced in the stator winding, this magnetic field also gets induced into the windings of the rotor, and just because of this magnetic field the rotor starts rotating, like in such a way that, like suppose there are two magnets NS and S, similar poles repels each other. So this is the same principle over here guys. The rotating magnetic field is having some polarity and the rotor is also having same magnets. It means guys, over here the two magnets gets induced, two electromagnets are present in this motor windings. So these different poles try to repel each other. So this is the same principle, and just because of this principle the torque gets induced in the motor, and the motor starts rotating. So it is very simple, and the motor starts rotating. So this is very simple, and by altering the frequency of the power supply AC power source, we can alter the speed, we can alter the RPM, and this is the reason the three-phase induction motor is used along with the variable frequency drive, so that we can adjust, we can increase or decrease the speed of the rotating motor. So guys, this is nothing but the main principle behind the working of the three-phase induction motor. Over here the main two important factors are there. This is nothing but the rotating magnetic field and this rotor. So the similar poles tries to repel each other. So this is the principle behind the working of the three-phase induction motors. Now let's talk about some of the features. These three-phase induction motors does not require any starter motor. The construction is very rough and rigid construction. It is also having a less maintenance is required. So that's why it is used in the most of the industrial applications. These motors are highly reliable and highly proficient. These motors does not use the permanent magnets that we have seen in the DC motor. Also, it does not require the brushes. which is there used in the DC motors. We can achieve the different speeds by using the variable frequency drive in this case. So friends, these are nothing but some of the features of the three-phase induction motor, and just because of all of these features, it becomes a best choice for the various applications. And nowadays guys, these induction motors are being introduced into this electrical vehicles. The Tesla cars uses the synchronous induction motor. Well guys, over here the word that is the synchronous. So the synchronous speed in the induction motor, it is the maximum speed that is achieved by the rotating magnetic field, and the motor is always run just below the synchronous speed of the magnetic field, as the rotor is tries to catch up with the EMF. So over here guys, the rotor rotates at a less speed than that of the synchronous speed. So this is how a three-phase induction motor converts the electrical power supply, electrical energy, into the rotating mechanical energy. And guys, in the vice versa, if the rotating magnetic field's speed is become less and the rotor speed becomes more, so in this case the motor becomes a generator. In this case the motor starts generating the electrical energy, the mechanical energy gets converted into the electrical one. So this is the difference between this induction motor and the induction generator. So guys, I hope you like my video. If you're having any queries, any doubts, please leave a comment, and please do subscribe to my education channel GS Academy. Thank you so much guys, keep supporting me, and also please support me on patreon.com so that I can continue with my work, with my educational service. Thank you guys.